Welcome, and in today's chemistry lesson, we'll be talking about valence and chemical formulas. So basically, how do we determine the valence from the periodic table? So here we know to say the periodic table is divided into two types of elements. We have the metals and the non-metals. So if we follow this zigzag from boron there, going down like this, all these elements this side, they are non-metals. Then if we follow these metals here, these are what? Metals. So now, the arrangement here is that how can we determine the valence for both metals and non-metals from the periodic table? So to determine the valence, so we have to say we have metals and we have non-metals. So in order for us to determine the valence for a metal, the valence is always equivalent to the what? The group number, or the valence is always equivalent to the number of electrons in the outermost shell. So here, for all the metals that you have there on the periodic table, apart from the transitional elements, because these transitional elements, they are metals, yes, but their valences, they differ. Sometimes today we can be given copper 1, copper 2, copper 3, and just like that. So here, the valence change, but we are talking about elements in group 1 and 2, and part of those ones in what? Group 3 and 4. So there, the group number, or rather the number of electrons in the outermost shell, will give you the valence. So meaning we are saying the valence for metals is equivalent to the group number. So if an element belongs to group 1, meaning the valence is also what? 1. If an element belongs to group 2, meaning also the valence here is what? 2. And then this tells us to say this element has got 1 electron in the outermost shell, this one has got 2 electrons in the outermost shell. If you go back to the other video where we are talking about how to determine the number of electrons in the electron configuration. Then now, for non-metals, it will be 8 minus the group number. So to determine the valence for non-metals, we are going to say 8 minus the group number. So basically, if an element is in group 7, to determine its valence will be equivalent to 8 minus what is the group? 7, which is going to give us what? 1. So meaning for all the non-metals that we have on our periodic table there, to determine its valence, we are going to say 8 minus the group in which this element belongs. If we pick an element in group 6, the valence there will be equivalent to 8 minus the group, which is 6. So this will be equivalent to 8 minus 6, we get 2. So meaning this element has got a valence of what? 2. But now, how can we marry this information together? We know to say, for all the metals, the valence will be equivalent to the group number. So meaning if an element is in group 1, meaning its valence is what? 1. Again, meaning this element has got 1 electron in its outermost shell. But what about this one here? We know to say, if an element which is a non-metal is in group 7, we are going to say 8 minus its group number. Then the valence there is going to be 1. But with the knowledge from the previous video there, we know to say the group number always tells us the number of electrons in the outermost shell. So meaning for non-metals, this 7 is the number of electrons in the what? In the outermost shell. Then the valence is going to tell us how many electrons this element needs in order for it to be stable. Now we see that one, right? So meaning this one is an element in group 6, and it has got 6 electrons in the outermost shell, and then it needs 2 electrons in order for it to be stable. Also, this one here is an element in group 7 with 7 electrons in the outermost shell, and it needs only one electron in order for it to be stable. But for the metals, it's simple and straightforward. Where we know to say the valence is equivalent to the group, meaning it has got one electron in the outermost shell, meaning this is the electron that it is going to give out. So now, with this knowledge now, how do we write the chemical formulas? How do we write the chemical formulas? So in order for us to write the chemical formula, let's say for example, we take an element in group 1, which is sodium, and then we take another element from maybe group 7, which is chlorine, like that. So in order for you to write the chemical formula that is going to be there when sodium and chlorine come together, we know to say we are going to write our symbols like this, respectively. This is sodium and then this is chlorine. Then what is the valence for what? Sodium. Sodium is a metal in group 1, meaning its valence is what? 1. Because it is in group 1. For all the metals, the valence is equivalent to what? The number of electrons in the outermost shell or the group where it belongs. But if we go to chlorine, chlorine is an element in group 7, meaning it's a non-metal because it is across the boundary there. So meaning it's a non-metal. So for that non-metal, we are going to say 8 minus the group number, which is 7. We are also going to get what? 1. Then how do we write the chemical formula? We cross multiply the valence. So we are going to say this is sodium 1 and chlorine 1. So in mathematics, we know to say when you are having a 1 there, it's just the same as not indicating it, because we know to say we are only having one atom for each element. So if we check, this is the chemical formula that is going to be there between sodium and chlorine, which is basically sodium chloride. If we pick another example, let's say for example we pick magnesium and fluorine. So if we write our magnesium like this and our fluorine like that, we know to say magnesium, this is an element in group 2, so meaning its valence is 2. Then we know to say fluorine is an element in group 7, meaning its valence there is what? 1, because it will be 8 minus 7, which is 1. Then now we can cross multiply. So we are going to get magnesium 1 and fluorine 2, like that. So meaning we are going to get magnesium fluoride, where we know to say there we are only having one atom of magnesium and we are having 2 atoms of what? Of fluorine. If we have to pick another one, maybe we say, let's try we pick both non-metals. Let's say for example we pick calcium, we pick carbon, and we also pick oxygen. So if we write there symbols like that, calcium is a non-metal in group 4, and also oxygen is a non-metal in group 6. So here we know to say, since this one is in group 4 and it's a non-metal, we are going to say 8 minus 4, which is going to give us 4. And then oxygen is an element from group 6. So we know to say 8 minus 6 we get 2. So the valence for that one is what? 2. Then now we can cross multiply the valence. We are going to get, this is carbon 2, and oxygen what? 4. But mathematically we can't leave it like this, because we know to say there is a number that can go in both the numbers without leaving any remainder. And that number is 2. So if you say 2 there, 1, 2 there, 2, which is going to give us carbon, and the oxygen, which is giving us what? Carbon dioxide. So basically you can pick any from group 1, group 4, group 1, group, anything you can try. So basically this is how you write chemical formula, and that's how you obtain the valence. It's very important for you to know how to determine the valence, because the valence is very important in writing all of these compounds that we write in chemistry. So make sure to join us again next time when now will be showing how these atoms are coming together chemically, which is basically bonding. So we'll be talking about bonding in our next video. Thank you very much.